Welcome to another new video. Today we are going to delve into the world of predictive modeling applied to photovoltaics. Can you imagine being able to anticipate power generation, plan the maintenance of your solar plant, and optimize future performance? All this is possible thanks to data-driven predictive models. The key is to learn from historical data to predict what will happen in the future. Let's get started. A predictive model is a tool that uses historical data to make predictions about future events. In the context of photovoltaics, these models help us to predict energy production and possible failures of plant components. Basic algorithms. The most common algorithms used in these models are linear regression, decision trees, and more complex machine learning algorithms such as random forest or neural networks. Predictive model lifecycle. The life cycle of a predictive model starts with data collection, followed by model training, validation, and finally the use of the model in a production environment. Predictive models are essential for anticipating plant behavior and making proactive decisions. One of the most common applications of predictive modeling in the PV sector is the prediction of power generation. Factors affecting production. Power generation depends on multiple factors, such as solar irradiance, ambient temperature, and the condition of the solar panels. Predictive models take these variables into account to make accurate estimates. Regression models. Linear regression algorithms are useful for predicting daily or monthly energy generation based on historical data and weather forecasts. Time series. To predict how generation will change over time, we use time series models, which identify patterns and trends from historical data. These models allow you to adjust the operation of your solar plant based on predictions, optimizing performance and maximizing revenue. Another key use of predictive modeling is predictive maintenance, a strategy that allows you to anticipate plant component failures before they occur. Critical component failures. Inverters and solar modules are the most common components to fail in a PV plant. Predictive models can identify patterns in operational data that suggest when failures are likely to occur. Machine learning for failure prediction. We use algorithms such as decision trees or neural networks to classify operational data and predict when a failure will occur based on historical patterns. Maintenance optimization. Predictive maintenance allows repairs to be scheduled before failure occurs, minimizing downtime and reducing operating costs. Planning maintenance in advance, based on accurate predictions, will help you reduce costs and increase the lifetime of your equipment. Implementing predictive models in a PV plant requires adequate infrastructure and continuous improvement of the models to maintain their accuracy. Cloud infrastructure. Many solar plants are integrating their predictive models with cloud platforms such as AWS or Google Cloud to process large volumes of data and update their predictions in real time. Model optimization. It is important to recalibrate models on an ongoing basis. This is done by adjusting the hyperparameters of the algorithms and adding new data as it is collected. Model validation. Models should be validated regularly to ensure that their predictions are accurate. This is achieved by comparing predictions with actual results and adjusting the model where necessary. With the right infrastructure and a continuous improvement approach, predictive modeling becomes a key tool for the operational optimization of any PV plant. As we have seen, predictive modeling offers enormous benefits for the optimization of production and maintenance of photovoltaic plants. If you would like to implement this technology in your solar project, do not hesitate to contact me on LinkedIn. Data is the key to anticipating the future of your solar plant, and predictive modeling gives you the power to optimize your operation. Are you ready to take your plant to the next level?